Hello everyone and welcome back to our channel The Coding Arc. In our previous video, we have already learned how we can use some of the commands already present in our Linux terminal to look for detailed information on specific commands. Now, we also learned most of the common commands in Linux command line like ls, pwd, mkdir, rm, and so on. Okay. So in this video, we are going to learn how we can expand and join commands using metacharacters. Then we will see how files and folders permissions work in Linux. Then we will go and see how Linux interprets the file type even without a dot extension. And finally, at the end of the video, we will see a simple Linux bash scripting. Okay. So the first topic is metacharacters. Metacharacters are nothing but special characters that have a special meaning in the bash shell. So there are total of six special characters or metacharacters that we are going to go through in this video. Uh, okay, so I will start with the first metacharacter, that is the pipe character. You can click on shift and then a forward slash to get this pipe character. This pipe character is a very powerful metacharacter in our bash scripting because it connects the output of one command to the input of another command. It also allows us to chain multiple commands in a sequence where the output of first command becomes the input of second command and so on. So let's see an example, that is cat slash etc slash pawswd. We already know what a cat does, but I will still give a brief overview on it. So the cat character, the cat command will basically give us whatever the content is present inside the password file, which is inside the exector directory, which is inside the root folder. This backward slash is the root, then this is the directory in which the password file is. Then after that, what we'll do is we will pipe it. So whatever the output of a cat command will be, or whatever the contents of password file will be, we will give it to a command named sort, which will basically sort it alphabetically without any default arguments or without any options. It will simply sort it alphabetically by default. If we can change its behavior using different options, you can go through it using the manual page given in it. Then we will give it to less. So what less does is it simply takes whatever the output sort does and displays it in page by page format. So it is basically very useful when you want to go through a long, you can say a very long file. Okay. Because it basically makes up pages of those files and you can go through it page by page. We'll do enter, and as you can see, each of these is alphabetically sorted, and we can press enter, 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 or space to go through it page wise, and q to quit. Okay, so we are done with cat. Okay, I will show you another command of the of the pipe command. So let's just say we did ls. You already know what ls does. Ls simply stands for list files and directories. So what it does is it simply lists the directories and files in our current folder. Okay, so if we do ls and whatever the output is, we will pipe it to wc. Okay, wc is simply a command that is used to count certain things. We will count the number of words, because as you can see, each file name has a single word, or you can say each directory has a single word. There's no file in my home directory, you can say. So if we do that, it will give me the total number of directories and files which is present inside my home folder. If we just do a quick count, so 1 2 3 4 5 6 7 8 9 10 11 12 13, we have total of 13 directories inside of our home folder. If we do this, it will still give us the same 13. Yep, so here it is 13, which is the total number of directories present in our home folder. Okay, so these are the some examples of cat command. Next we will go and use the ampersand command. Ampersand command, you can simply use it by typing shift and 7. Okay, so what it does is it simply makes a process run in background. So for example, there are some processes in our Linux system that take a lot of time to complete. Okay, okay, so the second meta character is ampersand. It is basically a very powerful, it is again a very powerful it has a very powerful use case in our Linux scripting systems. So what we can do is there are some commands in our Linux system which can cause our terminal to be occupied for a very long time, such as compressing files, updating, and different sort of things. So if we want to use our terminal, we cannot use it. So what our option is, we can make it run in background so that our terminal is free and you can use it for some other work. So an example is gunzip command. What it does is it simply compresses a file into a zip file. You can give whatever if you have a very large file in your system to that, and just write whatever the file name of it is and run it. You will see that the command like this command will occupy a lot of time resources as because it requires a large amount of time to be done. So instead of that, what we can do is make it run in the background. So it won't be able to run in the back foreground and make your terminal available to you for other purposes. So for example, there's no such file in as gunzip or test job zip. Okay. So the third command is semicolons. The third meta character. Okay, say. So the third meta character is semicolon. Uh, it is used for sequential running of commands in a single line. So, for example, if I do that, let's say mkdir, I want to create a file or you can say folder named dir, let's say 5, and again I want to go get inside the dir5. So, we will change the directory to dir5. Oh, sorry. After that, what we can do is I will create a file named, let's say, new.txt here. So what will happen here is it will first make the directory name dir5, go inside the directory 5, and then create a new text inside there. But so if I do this and do a ls, you can say a new.txt file has been created and we are inside the directory 5. This is how you can make the commands run sequentially one after another, and it is a very useful command when you want to run commands sequentially in a single line. Okay. So the next is right and left parentheses. So these parentheses are special characters, also special characters. They are basically used for grouping commands. So you can say this is also used for, we can say that controlling the order of execution, or we can also create or expand logical groups. So for example, let's say I do echo hello, and then I will do echo world. So what will happen here is a subshell of the bash will run this command, and whatever output is given, we will just say pipe it to the word count. Word count by default will give us the number of words, characters, everything. So I will just do characters. So since I only want the number of characters that are present in it, or I can just use W to get the number of words that are present in hello world. Okay, so it will give us two. So what happened here was the first thing, these two echoes were run one after another in a subshell. Whatever output came, we gave it to word count and it gave us the output. Another use of this is for expanding different variables. So for example, let's just say I want to know what is today's date. I will type hello, today's date is a dollar to I will get to know, I will get to it what this dollar sign represents and what variables are in the command line. But for now, I will just show you a demonstration of it. So what we'll do is uh, this is simply the text that is going to be printed, but the date variable has the current date, and it will be, instead of the date, that current date will be substituted here and given to us as output. And you can say that today's day is Sunday. This is the entire date that we have currently got by running the command. Okay, another one is the greater than and less than meta characters. So what they do is they are basically used for inputting or redirecting to input or redirecting to output. So basically, they allow you to control how data is sent and received from commands, files, or other sources. These redirection operators are powerful features of the cell and they enable all you to manage data efficiently. We can say that. So what we can do is we will do cat. Okay. Let's just say we are in where we are. Yeah, this is a new.txt. So this has nothing in it. You got it. So what we'll do is cat new.txt. Now what will happen here is whatever is the content of new.txt will be given as an input to the command cat, which will basically show us the whatever is present inside. This is how internally cat actually runs. But if we do this and give an output redirection or a greater than symbol and then type new.txt, what will do is whatever is the output that we will give to cat, it will basically overwrite it into the new.txt file. So if I do that, we will do hello world and we will just do control D and then again do cat new.txt. We'll see if hello world has already been written in it. Now, if I do this again, let's say cat new.txt and write hello and write again hello and then give control D. What will happen is whatever is the content of new.txt, it will be overridden. Okay. Yep, you can see that rather than being appended, the contents of hello new.txt got overwritten. If we want to append it, what we can do is instead use two output redirection operators and then new.txt, or you can say the argument. So hello, we already have hello. Let's just append world to it. Enter control D, and we can say cat new.txt has hello world in it. So I hope you got to understand how we can use these different meta characters in our bash scripting. So the next part is how files and folders permissions work in Linux file system. Okay. So whenever we do ls and give it an option of long listing, okay, we'll just go to the home directory and do it again here. There, you can say. Yep. Whenever we do something like this, and it will give us a series of characters that we don't understand. Okay. So we will know how we can interpret those symbols and what those symbols mean. So let's first create a file here and do that again. Ah, okay. So I've given it as a long list and shown all the hidden files here. So there are total of four groups here. As you can see, like these sequence of character contain a total of four groups. So the first group is simply the first character itself. That is, you can see the D here or the dash here. Uh, so what this D shows that whatever this is a directory. And if we find a minus symbol or dash here, it simply means this is a file. There's also something called as an L, which shows a link, but the this course does not cover that. So just remember these are the three things that the first character represent: either a directory, a file, or a link. So after that, we have these three groups remaining. These three groups have three characters: these, this, uh, this, this, and this. Okay. So the first group, that is this one, represents the user. So there can be multiple users in the Linux system, and they each can create their own files and folder. So this represents what they can do with their own files and folders. It is usually read, write, execute, which basically means they have all the permissions to read it, write it, and even execute it. Okay, so after that we have another group, that is this. This is for the groups. As we know, they can be multiple people working at the same time in the Linux. So there are times where some people require files or folders from other people to collaborate and work on something. So what we can do is we can include them in a group where they will get all those files and folders as well as the privileges to write, read, or execute them. And this is for all the other people, okay, who are not in the group, who have not created this file. Oh no, this is different from the administrator privileges because administrators have all the access to all the files and folders. So now we will see how we can change this. So what we can do is we can use chmod. This is basically used to change the, you can say permissions for different users and groups. So what we can do is, let's say I want to change. So let's say we have new.mp4. Now I want to change its permission. I do not want an execute permission for anyone here. So what we can do is, let's just so what happens here is I can just use -x, that I do not want an execution permission here, or you can use oh chmod. Okay, so what happens here is we can use chmod command to change the permissions for different files and folders. So let's just say we want to change the group permission. Okay, group permission to, let's say this is a file. We have read, write, execute permissions here. I only want an execute permission here, or let's say I just want a group. People who are in the group can only read it, who are in my group. So I will do new.mp4, mp4, enter, and then when we do ls that l again, as you can see, it has only read permissions, and write and execute and write permissions have been taken from it or overwritten. So if I want to let's say I want to change the permissions for them together. There's something known as place. Let's If you know binary, you will get to know it very easily. But if you do not know it, don't worry. It is still easy. So let's say this is the group for others. The first character or the first placeholder has a value of 1. Second placeholder has a value of 2, and the third folder has a place value of 4. Okay, so each of this group have 3 place holding values, that is 1, 2, and 4 for all 3 characters and for all 3 groups. Okay, so what I can do is chmod. I can do is I want all the permissions. I will change it in file. So I want read, write, execute for user, and I do not want to change anything. Okay, so we will do it 0. And if we do that, and if we do again, as you can see, I have gotten all the read, write, execute permissions, and nothing has changed for others. This is how you can change it. So let's move on to the next module now. Okay, so the next thing we're going to study is how Linux identifies the type of the file. Okay, so as you have already known, since I've talked about it in the previous video, basically we do not have extensions. Like, there's no meaning to extensions in Linux. For example, if I create a file named new, let's just say file.txt, and then this has no meaning in it. Even if I do just file, it will still interpret it correctly. The Linux system will still interpret it correctly. So how does it do that? So what happens is, in Linux, the type of file is determined based on its content rather than the file extension. So let's just get to it. This is the file extension .txt. Rather than decided by what type of the file is by its extension, there's some characters, or you can say magic numbers inside of a new file, which basically is how Linux determines what type of file it is. So the Linux, when we create a file, the operating system does not inherently know its type. Okay, so it is a collection of binary data. You can say that everything is binary to computer. However, the beginning of many file format contains a specific pattern of byte known as magic number or signature. So Linux has a database of these magic numbers to identify which type of file it is. When you basically try to open or create a file, such as, let's say I want to open a file named nano new.txt. I want to open a file new.txt, and nano is a basic editor which is provided in the command line with other things. So you will find it in everyone. If you do not have nano, or you can still use different command editors such as vim to or gedit to do the same thing. So whenever I press enter, it knows that it is a text file, and it opens this for us. If I do new hello world, let's just say control O to write, enter, and then control X, we have saved some text in the file. Now let's just create another file. uh, let's give it file, and what we'll do is, okay, so what we'll do is after that we'll do we'll also insert some text in it. So let's just say I will insert hello in it, control O, enter, control X. So we have total of two files, both are text files. One is without an extension, that is new.txt. uh, Sorry, one is without an extension, that is file, and other has extension that says .txt, that it is a text file. So what it will do is, whenever we open it, okay, whenever I open it, nano file, it shows this is a text file. And even if I open new.txt, it shows this is also a text file. So what it does is, there's some few bytes at the beginning of the sequence which shows what type of file it is. This way it can recognize different types of files such as mp4, jpeg, pdf, etc., even if the file extension is missing or incorrect. For example, if I just do new.txt to new.jpg, okay, now we do nano new.jpg, you can see we still have the hello world here. It is still interpreted it as a text file. Even if we run it, oh, okay, we do not have permissions to run it. So as we talked in in the previous module, we can use chmod to edit the permissions. Let's just do it, 777 and new.jpg. I'll give every permissions to everyone because I'm the current owner right now. And if we do new.jpg, okay, it ran hello. As you can see, it is still interpreted as hello. So we can see uh, what type of a file is based on its content. So we have a command known as file. When we run the file command followed by the file's name that we want to see, that is as an argument, that is file.jpg. So what it does is, it will read the first few bytes of the file, match them with the magic numbers that is present in its database, and then determine the file's type. So if I do that, as you can see, even though it has a jpg in it, it is still asserted that it is it is a text file. Even if I do mv new dot, let's say mp4, oh sorry, mv new dot jpg to mp4 and do that again, it's still determined that the file is an ASCII text rather than a movie or a video or a image. Okay, so as you can see, file command correctly identifies the type of file based on their context irrespective of the file extension. This file type determination mechanism is one of the reasons a Linux system can handle the file more flexibly than relying solely on file extensions. Okay, so the last point that we want to make is, let's create a simple bash script. So up till now, what we have done is we have seen how metacharacters work, what are the uses of metacharacters in bash shell. We've also seen the file permissions, how we can change file permissions. We've also seen that how Linux determines the type of file. Now what we'll do is create a script. Uh, so what are the benefits of creating a script? First of all, let's say there are certain commands that you want to run again and again uh, to do a certain things, and you want to do it every day. Now typing tens or hundreds of commands every day will definitely not be good for you. So what we can do is, to automate these, we can keep all those commands in a file and run the file itself. So let's just create a file named nano uh, scri script.sh. Remember, this extension does not mean anything, but this is how mostly scripts are written. But remember, this file extension has more meaning. Okay, so the first line what we will do is, we'll use a hash and an exclamation mark, then bin slash bash. So why did we do this? So what it tells is, whenever we run these script, whenever we run this script, it will always run it in bash. So there are multiple bash such as ZSH, multiple scripting languages such as bash, ZSH, CSH, and others. And if you are using ZSH to run bash script, obviously there may be certain problems to run it. So if we do this, it will essentially tell the interpreter to run it using bash rather than any other scripting scripting language. Let's just say ls. What we did was, uh, okay, another thing I want to tell you is, uh, anything written here will be ran sequentially, line by line. So first this will be ran, or this will not be ran because it is just instruction. So the first this will be ran, this ls command will be ran. Then what will happen is this cd command will be run. Or let's say I did ls. Now, since we have got the directories, what we can do is, I want to count the words in it that we've already done before. The same program will run it again. Control O to write, enter, and then Control X to exit. We see we have a script.sh, but we cannot run it because we do not have permissions for it. So we will just do L and C. As you can see, we do not have an execute permission. So what we can do is, we can do chmod, and then since I'm the owner of it, I just wanted to change the permissions for the owner. So I want 7 for the owner, and then I think I don't want anything for the users and the other people. You could say the group and the other people. So I'll do this and just cript oh, script.sh. As you can see, we've got read, write, execute permissions here, and we've changed nothing here. So let's just run it dot slash script dot sh. Okay. So there was a problem here, and interpreted as this is the root folder, and this is where under the root folder we have the bin. So it interpreted it as the first folder is the bin. So this is the problem we got. We will do control O, control enter, and then control X, and then run it again. Okay. Uh, okay. Oh, I got it. The problem was when I did WC or word count, whatever the output was not given to WC, the word count command. Rather, these are separate commands, individually separate commands. If we want it to run like that, we need to give it an input and then count it. So let's just use another command instead here. So we will echo command finished, and we will write it out using control O, enter, and then exit. Then we will run it again, and this is how it works. The first command ran, then after that, second command ran. But the input of first, or you can say the output of the first command was not given to the second command. For that, we would need to use a special metacharacter known as pipe. Okay, so in this video, we have learned how you can use, or you can say, so in this video, you have already learned what are metacharacters, how you can use it for different operations, how the permissions work for different files and folders in Linux, how Linux interprets file type even without a dash scripting, dot extension, how the Linux interprets the file type even without a dot extension, and finally, we have written a simple bash file. So in the next video, we'll continue on and so in the next video, we will continue with bash scripting. Thank you.